Hi students, as we conclude week number 2 and begin week number 3 of the semester, most of you are starting chapter 3 in your textbook and in Connect, and that's exactly where you should be. And as you do that, you are starting to understand what is going to be my quick tip number 1 is your calculator is lying to you. How could your calculator be lying to you? Well, it is, and I'm going to tell you how, and this is a very common mistake that students make. Now, my calculator, if I haven't said this to you already, I will say it to you many times throughout the semester, is Excel. Excel is just a big calculator, very smart calculator, and what's true on Excel is true on your calculator regardless of what calculator you have, all right? Let's say I'm going to do a calculation. I'm going to say 22 divided by 7. Now, maybe in your calculation, you're doing standard deviation of a sample or standard deviation of a population and something like this. And you have your numbers and you're adding and subtracting, multiplying, dividing. And when I enter that in, I see that the answer is 3.1429. And I say that's great because my calculator is giving me the number with 4 places after the decimal. But is it? What your calculator actually knows is that the answer is not 3.1429. Instead, it's the answer to what you did to come up with it. In this case, 22 divided by 7. So what your calculator is actually very aware of is that there are many places after the decimal, and your calculator knows them all, okay? So when you are simply displaying 4 places, let me get down here, 4 places after the decimal, and then you take that number and you use it in another calculation. In Chapter 3, standard deviation and mean deviation, this is when these problems appear because what you think is that you say, okay, I'm going to take that number, you stored it in your calculator, like it's in store number 1 or store number 2, wherever you stored it, and you multiply it by something. Well, now let's think about this for a minute. The last number, 3.1429, I just multiplied by 2. How could this be 7? 9 times 2 would mean that it should be 18. 8 carry your 1, right? How is that a 7? Well, let me select these and increase the number of decimals. Well, wait a minute. Watch those numbers again. 3.1429 is actually 3.1428 with a 6 that follows. Your calculator was kind enough to round it for you and to display the answer to you with 4 places after the decimal, but when it did the next calculation, it used all of those hidden values after the decimal. And what that means is that you're actually introducing error into your work because the rule of significant digits, and if you don't remember that, you can go look that up, says that you cannot carry all these places after the decimal because as you do calculations, that actually introduces error. So periodically you have to fix that. How do you fix it? Because if you tell me, well, no, not my calculator because this is what I see on the screen right there, I'm telling you, your calculator is actually aware of something like 18, 24, maybe even more places, decimal values than that. So what do? Tell you what you do. You write it down on a piece of paper and you label it, okay? A good thing to do might be to say this is, now you could write mean, sample mean, but for us we like to say this is my X bar value. What is X bar? X bar means this is the sample mean, the average of the sample. Now I can't get the little bar on top of the X on my computer, so I just wrote that out as X bar. And I would retype that number, 3.1429. That is the number, not with all those decimal places that I'm not even aware of. So I wrote it down on a piece of paper, I labeled it so it's not just this chicken scratch that I don't remember what it is and I type in a wrong value. I'm organized, I'm neat in my approach. Now, I'm going to take this number and I'm going to multiply it by 2. Oops, multiply it by 2. I said, having a little difficulty here, I'm going to multiply it by So look at the difference in this answer. These are two different answers, and Connect might mark it wrong. You say, well, that's frustrating. That is close enough. You should give it to me. Well, nope. The truth of the matter is you carried in this calculation, without even realizing it, you carried a whole bunch of extra erroneous, flawed data values. That's not accurate out to all these, in the calculations you're doing. It's not accurate out to all those decimal places. So you do need to rewrite it. Now, lest you feel unjustly misscored, let me explain something to you. Let me go over to this Connect system. After you submit your work, I really encourage you to go back in and look at your answer, and you can click the green key up here and you'll see what Connect says the answer should be. Now, as I look at this, let me tell you how to read it. This is the correct answer, 103.1. So what does the rest of this stuff mean? This means plus or minus, and this is how much plus or minus. Right now, you're calculating standard deviation and variance, well, in range, things like that. This means that if your answer is within this range of values, that Connect will mark it as correct, even though it was a little bit off, okay? So, what if you had typed in that your answer was 103.11? Well, that would be, let's take that number, 103.1. I'll do this in my Excel calculator, 103.1, and it says an acceptable value could be plus 0.05, right? That would give us an answer of 103.15. Well, I said, what if you typed in a number like this? Well, this number is within the range. So the correct answer is 103.1. Your answer could be as high as this number or as low as 103.1 minus. Remember, we said plus or minus 0.05. Isn't that what it was, 0.05? So if your answer is between this value or that value, then Connect is going to mark it right. Good for you. That sounds excellent, doesn't it? And it is excellent. It's very fair. But think about your calculation for mean deviation or for standard deviation. You would use this number that you were wrong just a little bit. You had 103.11 because maybe you had a rounding error. And you're going to use it over and over as you perform those other calculations. And what that means is that you've introduced error, and it's going to snowball on you. So much so that when you get ready to type in the mean deviation or the standard deviation, you're going to be beyond what is acceptable as an answer for those later values, those later answers. Consequently, you're going to get it wrong. You say, well, that's not fair. It should mark me wrong to begin with. Well, maybe, okay? How do you get the right answer is the more important thing. When you go back and you check your work, even if something has been marked right, you should have it to exactly the same value as Connect says. If you're using this tolerance, then you are not rounding in the way that Connect wants you to round. How do you round? You take that number, 1.3429, and you retype it. Don't store it in your calculator. Don't put it in one of those little registry values. Write it down. Make sure you know what that thing you just wrote down is, so label it. And then retype it. Clear your calculator. Retype the value in. That'll keep you on the right path. Now, as a final thing, if you really get stuck, don't forget that you can copy. I'm dragging over. Right-click copy. And if I went to, hang on just a second. I go to a Word document, I can paste, and then you want to tell me what values did you get, what steps were you taking. Attach that to an email. Attach that to an email that has simply J. McGrory at the to line, a relevant subject, a well-written note that explains what you've done. You can attach the Word document to your email down here, and then you click on Send in this far right corner, and I will look at what you've done and try to help you. Hopefully this quick tip helps you get over some hurdles. It will be important for the remainder of the semester. Thanks.